Right, chaps, this is the second part of the same lesson. I think because it's quite a difficult one, I thought I'll do one more example to explain Professor Pupik's ideas a bit better. So what we're going to do now, we're in, by the way, page 315, example 2. And we go look again at tossing a coin, but now not twice, but 3 times. So it's a compound event made out of 3 separate events. Now, to start drawing a two-way table is, well, we can't. We need a 3-way table, and it's actually very difficult to do in 2 dimension. So in more complicated problems, we're always going to use tree diagrams. That's really the way on forward, tree diagrams. Okay? So we're tossing the coin 3 times. Now, the first time we toss the coin, okay, I should have written that actually here. First time, first toss, we either got a head or we got a tail. And remember, we put on the branches, what's the probability? So the probability of getting a head is half, the probability of getting a tail is half, because it's even chance. Now, the second time I'm tossing it, I'm going to draw it here, second toss. Again, I can either get a head or a tail. So if I got a head in the beginning, I can either get a head or tail in the second one. If I got a tail, again, I can get a head or a tail. And then I'm tossing it again. This is the third toss. And again, if I got the head the second time, I can get a head or a tail. If I got a tail, I get either a head or a tail. Head, tail, head, tail. Now let's have a look at what actually did I get compounded. So if I went through, before that, probabilities. Probabilities of getting head or tail is half and half. It doesn't get affected. Or each branch by itself, the probability of getting it is half. Okay, so all these events are half. Okay? Later on, we're going to look at maybe some probabilities where are not exactly even. Now, what did I go? If I go through this whole branch, so what did I actually get? I got a head, and a head. So the probability is, what event was it? It was head, and head. That was the probability. Let's do a different color so we can separate it. So it was head, and a head. What did I get if I went through this branch? Well, I got head, and a tail. Head, and a tail. Here I got head, tail, and a head. Here I got head, tail, and tail. Now you see what I'm doing? Easy. I'm just going through each branch and collecting all the wood. Okay? Tail, head, and head. Tail, head, and tail. Tail, tail, and head. Tail, tail, and tail. I think it's very useful to do that before you even start answering the question. So now we can answer the question. Let me just pause you here. Okay, so the first probability we need to find is what's the probability of getting 3 heads? Okay, now let's use what Professor Pupik told us. Probability of getting 3 heads is the probability of getting head, and then probability again getting a head, and probability again getting a head. What did Professor Pupik told us? He said, what we're going to do, if the word is and, I want to get this, and this, and this, I need to multiply all the probabilities. So it's going to be half time half time half. And that's 1 over 8. Okay? The rules that I've written here, okay? If I have 2 events, A and B, and I want to know what's the probability of getting A and then getting B, what I got to do is, write it in purple, I need to find the probability of getting A and multiplying it by the probability of getting B. So when I have the word and, usually I need to multiply the probability. Here, I have to multiply half time half. Okay? Right. Next one, they ask me, what's the probability of getting 2 tails followed by heads? So probability of getting 2 tails and then a head. Okay? Well, which one does that fit? So 2 tails and that head. That's this branch. So again, I can say half time half, which is another 1 over 8. Okay? But let me just show you in another way you can do it. Okay? Each one of these events have an equal chance. Chance of getting 3 heads or 2 heads and then a tail are equal. Overall, how many events I have here? If you can count 1, 2, 3, 4, we get 8. So probability of each one of them is 1 over 8. Okay? Each one of these probability is an 1 over 8. So the probability of getting tail, and head, straight away I can say is 1 over 8. Okay? Let's move on to the next one. The probability of getting two that's a good one. Okay. So the probability of getting two heads and a tail. So 2 heads and 1 tail, but in no specific order. Okay, so now it's becoming a little bit more difficult. 2 heads and a tail in any order. Okay, when I've got in any order, that means either I'm getting, what can I get here? So 2 heads and a tail. So let's have a look at what probability am I looking at? 2 heads and a tail. Does that work out? No, that's 3 heads. 2 heads and a tail. Yes, that's fine. So that's 1. 2 heads and a tail. Is head, tail, head also 2 heads and a tail? Yes, of course. I'm going to circle it. Is that also 2 heads and a tail? No, that's head and tail and tail. Here, I've got 2 heads and a tail and 2 heads, so that qualifies as well. Here I've got 2 tails, so only 1 head. That doesn't qualify. Doesn't qualify, doesn't qualify. So the only probabilities that I have are those, the one I circled. How do I find the total probability? Remember what Dr. Pupik or Professor Pupik, sorry, Professor, I know, אני יודע שאתה פרופסור, אתה לא דוקטור, אבל התבלבל לי. Okay, I'm sorry. סליחה, פרופסור פופיק, הוא can be a bit grumpy sometimes, this one. לא אמרתי כלום. I didn't say. Okay. Right. How do we know if, when they want to tell us to calculate either that happened, or that happened, or that happened? Okay? So either I got heads and then tail, or heads and tails and that head, or tails and head. Each one of those are 2 heads and 1 tail in no specific order. How do I do that? Professor Pupik told us we must add, not multiply now, add the probability. So what I'm going to do is add an 8 plus an 8 plus an 8. Hope you guys can see that. Yeah, you can. So the probability is 3 over 8. So I know it's a little bit messy. I'm adding them together. To make it more general, okay, I'm just going to erase this. If I've got 2 events, A or B, and I want to calculate what's the probability that A happens or B happens, keyword here is or, then I got to do the probability of A and add it to the probability of B. You got it, guys? Okay, let's do the last bit, last problem. Okay? So, you know what? I just realized I made a mistake. Okay, so, sorry. I didn't make a mistake, but I wrote it in the wrong place. So, what I've calculated here is the probability of getting 2 heads and 1 tail is an 8 plus an 8 plus an 8 equals 3 eighths. You just check the book, see what's the next question. Okay, in our last question, we are asked to calculate the probability that we're going to get at least one tail. Okay, let's try and again circle all the events that qualify, that fits in. So where do I have at least 1 tail? Okay, we'll start from the top. Is this at least 1 tail? Head? Of course not. Okay, so we're not going to circle it. Heads and then tail? Yes, that qualifies. Heads, tail, and not head? Yes, there's at least 1. Heads, tail, and tail? Of course. Tail, heads, of course. Everywhere there's at least 1 T, at least 1. It could be 2, it could be even 3. It qualifies. So how many did I circle? I circled 7. Okay. So what I got to do, okay, like Professor Pupik told us, if I'm calculating the probability that at least 1 tail, that means it's the probability, okay, let's write the whole thing. It's the probability that, this is going to complicate, okay? So either that happened, or that happened, or that happened, or that happened, or that happened, either one of these events to take place, I need to add, okay? So it'll be an 8 plus an 8 plus an 8 plus an 8 plus an 8, 7 times, isn't it? Plus an 8, 1, 2, 3, 4, 5, 6, 1 more 8, and I get 7 eighths. Okay, of course, you could have just multiplied 7 times 1 8. Okay, but I just wanted to make it very, very clear. Huh? Just a second, guys. يفه. Very nice. Again, Professor Pupik, very clever guy. Okay? Yes, yeah, it's quite clever. You want me to explain to you something. Okay. So, I need to make some space. And I'll write it here. Okay, let's write it down. What Professor Pupik noticed, that, look, we had to add quite a lot of things. So to find out what's the probability that at least one tail we got, what we can do is find out what's the probability of that not happening. What's the probability of no tail? What's the probability of no tail at all? Well, there's just one. It's just that one. Let's circle it in purple. Only one event that took place where there's no tail. What's the probability of that? Oh, it's 1 over 8. Okay, all right, but that's not what they ask us to calculate. But then Professor Pupik tells us that the probability of at least one tail to take place, what we can do then is 1, like 100%, minus the probability of that event not taking place. Because what's the opposite of at least one tail? What's the opposite? Well, no tails at all. So to calculate the probability of one event to happen, what we can do is 1 minus the probability of this event not taking place. So it's going to be 1 minus 1 over 8, which is 7 over 8. Okay? Just going to make some space and add these notes for you. Okay, so just to finish up all these rules that Professor Pupik told us, we can add one more. And the probability for an event to happen, let's call it event A. So the probability for event A to happen can be calculated by 1 minusing the probability of A not to happen. So in this case, the probability of at least one tail to happen, we calculate by 1 minusing the probability that no tail to happen. Okay? In this case, it was 1 over 8. Alright guys, that's it for now. You can work on exercise 2 and I'll see you in the next lesson.